Welcome to In 5 Minutes. The agenda of this clip is to understand a ripple carry adder and its drawbacks. In the previous classes, we have already seen that if we want to add two numbers, let's take an example and start this. Suppose I want to add these two numbers. Say my input A is equal to 1 and my input B is equal to 0. Then if I'm considering the case of a full adder, I'll have some Cin as another input, and let's presume my Cin is equal to 0, then this 1 plus 0 would be nothing but a sum 1 and Cout equal to 0. So this is nothing but my addition of one bit number where A and B, both my inputs are of 1 bit. How does this translate to the hardware at the block level? Let's quickly see that. This is nothing but my full adder block diagram. Remember, in the further clips we'll be seeing how to make the transistor level diagram for a full adder, where my input A, as I had just seen, was a 1, my input B was 0, and my Cin was 0, which gave me my Cout to be equal to 0 and my sum to be equal to 1. So this was nothing but a classic block diagram of 1-bit addition. Now suppose if I want to do multiple bit addition, how do I achieve that? Okay, let's go ahead and see it real quick. Suppose my input A is 4-bit 1000 and my input B is again 4 bits 1110 and my Cin is also equal to 0. What happens is something like this. Pay attention because this will help us to enter into ripple carry adder. So if my Cin is equal to 0 and my A and B's are as given on the screen, this is what's going to happen. This 0 would be taken here, this Cin 0. So 0 plus 0 plus 0 would lead to a sum which is 0 and Cout to be also equal to 0, which becomes a Cin to the next stage. Remember, the Cout of the first stage becomes the Cin to the next stage. Okay, the next stage we have 0 plus 1, which leads to a sum of 1 and a Cout of 0. So again the same thing, the Cout of the second stage becomes the Cin to the third stage. Okay, in the third stage we have 0 plus 1, which leads to a sum of 1 and Cout equal to 0 again. The same thing again. The Cout of the third stage becomes the Cin to the fourth stage. And the final stage we have 1 plus 0, which leads to a sum of 0 and a final Cout of 1, which might go to further stages if we have them. So this clearly shows that if I am doing my multiple bit, in this case 4-bit addition, what's going to happen here is, starting from LSB, I keep on adding my inputs A and B along with Cin, and whatever Cout is produced, it goes to the next stage. So how do we represent this at the block level? Let's quickly go ahead and do it.